Hi guys, welcome to the lesson of ordinary differential equations. So in the previous lesson, we talked about the formation of ordinary differential equations. So now we are going to talk about the solution to first order differential equations, and we will start from the method of uh, variable separable. All right, so we will take some examples and we will see the general form of variable separable method. So if we have an equation that is dy by dx is equals to some function of y divided by some function of x, and we can separate the variables with respect to the derivatives. That is, if we can write in this form f of y times dy is equals to g of x times dx, then we call it variable separable, or we can also write it in this form, right? So it's same, no need to confuse about that. If I write here like this, that is f of x and g of y, or f of y and g of x. In fact, I should write in this way. That is g of x over f of y, right? So we can write in this form and then we can integrate to solve the problem, right? So let's take some examples on this method. So first of all, the basic example, if dy by dx is equals to x over y. Now we can see that we can separate this x with dx and this y with dy. That's why we call it the method of variable separable, right? So now we can write y dy is equals to x dx. Therefore, we can integrate easily. Now they are separated with respect to their derivatives. So it's y squared over 2 is equals to x squared over 2 plus c. Right now, if I want to write in terms of y, so I need to multiply 2 with the equation. So I can call it c1 because 2 times c is equals to c1. It's a constant. 2 times constant is equals to some constant, right? So I can write c1. So y is equals to plus minus square root of x squared plus c1. That is the solution for our problem. Now, let's take another example. Say this is dy by dx is equals to x times 2 ln x plus 1 divided by sine y plus y cosine y. Right now we can see that we can separate these functions, y with dy and x with dx. So let's write in this form: sine y plus y cosine y times dy is equals to x times 2 ln x plus x times dx. Now we can integrate these easily because these are separated, and we can write it as sine y dy plus y cosine y dy is equals to 2 times x ln x dx plus x dx. Right, and then we can integrate this function easily by using by path rule. So the derivative of this function is negative cosine y, plus for this we can apply the by path rule, so you'll get positive cosine y, and then plus equals to 2 times this is x squared ln x over 2 minus integral 1 over x times x squared over 2 dx plus x squared over 2 plus c. Right, and then we can simplify this negative cosine y plus y sine y, positive cosine y is equals to x squared ln x minus this x is cancelled with this now, so it will be again x squared over 2 plus x squared over 2 plus c. So this cancel out, and so we are left with y sine y is equals to x squared ln x plus c. So this is the solution for the given differential equation, right? Now let's take some other example. Now this is the question, that is x power 4 dy by dx plus x cube y is equals to negative sec xy. So now we can see that we cannot separate the variables from this equation, because here it's sec x times y and here the function is of this type. So what we can do is we can take x cube common outside, so we'll get x dy by dx plus y is equals to negative sec xy. Now we will try to make it variable separable by using substitution. Say u is equals to xy. So du upon dx will be equals to x times dy over dx plus y. Now we can see that we have this function here, this one, so we can replace du by dx here. So I can write x cubed times du by dx is equals to negative sec and u in place of xy, because we already suppose that u is equals to xy. Now this is separable, so I can write du upon sec u is equals to negative dx over x cubed. And finally we can integrate this. So this is cosine u du is equals to negative x power minus 3 dx. So it's sine u is equals to negative x to the power negative 3 plus 1, negative 3 plus 1 plus c. So now we can replace u with xy, and then this will be x power negative 2 over 2 plus c. So we can write it as sine xy is equals to 1 over 2x squared plus c. So in this way we separated the variables and we got the answer, sine xy is equals to 1 over 2x squared plus c. Now let's take one more example. So the question is cosine x plus y times dy is equals to dx. Again, we have x plus y, so we cannot separate the variable. But what we can do is we can suppose that u is equals to x plus y to make it variable separable. So it will be du over dx is equals to 1 plus dy over dx, right? So in place of dy over dx, we can write du over dx minus 1. Say this is equation 1. So from equation 1, now this implies that dy over dx is equals to 1 over cosine x plus y, right? So what we can do is we can write du over dx minus 1, du over dx minus 1 in place of this dy over dx, and then it's equals to 1 over cosine u, right? Because x plus y is equals to u, we already supposed that. So now we can write du over dx is equals to sec u plus 1. Now we can see that this is a variable separable equation. We can simply write in this way: du over sec u plus 1 is equals to dx. And now we can integrate this function. Now it's du over sec u plus 1. So what we can do here is simply we can manipulate this. So we can write like this: 1 over cosine u plus 1 is equals to x plus c, and then this will be cosine u du over 1 plus cosine u is equals to x plus c. And then simply what we can do is we can simply add 1 and subtract 1 here. So it will be like this. All right, this is some integration. You can just practice the problems of integrals to make yourself stronger in the integrals. 1 over cosine u du x plus c. Now this is 1, so it will be simply u minus, this is 1 over 1 plus cosine u, so we can write in this way: 1 over 2 cosine squared u over 2 minus 1 plus 1, right? Because cosine u is equals to 2 cosine squared u over 2 minus 1, right? And du, this is equals to x plus c. Now we can write u minus integral. This is cancelled out, so we will left with sec squared u over 2 and 1 over 2 here. Du is equals to x plus c, and we know that the integral of sec squared x is tangent, so it will be u minus simply tangent u over 2 is equals to x plus c. And then we can replace this x plus y instead of u, so it will be x plus y over 2 is equals to x plus c. So in this way we can further simplify this problem by cancelling out x and x. So we're left with y is equals to tangent x plus y over 2 plus c. So this is the answer. So this is the general idea of variable separable method. You can practice more problems from the reference books. There are a lot of books. You can get as many as problems you can for practice purpose. So in the next lesson, we'll come up with the homogeneous equations. That's all for the time being.